Hi, we're Team 14, and as part of the EGB320 unit, we have been tasked with designing a soccer robot as part of a modified RoboCup challenge. Advancements in technology has led to the development of autonomous robots capable of carrying out complex tasks. The robot's ability to perform tasks autonomously is especially desirable in space exploration, maintenance, and construction roles, which would otherwise pose a risk to humans. Although this project might not be saving lives, it's important to gain an understanding of the process that goes into making autonomous robots. The aim of this design is to be able to score 2 goals a minute while avoiding collisions with obstacles. To do this, the robot has been broken down into 4 major systems. These are the drive system, designed by Ben, kicker and dribbler, done by Max, computer vision system, implemented by Tom, and finally the AI and navigation system, done by Jake.
The vision system on board our soccer robot is based around the Raspberry Pi version 2 camera, as it is specifically optimized and configured to work alongside the Raspberry Pi on board. Here we give specific mention to the auto white balance and adjustable exposure features, which were used to create consistent lighting conditions within the camera feed. The vision system creates a continuous loop of frames, with each frame sent through color spectrum thresholding processes before being broken down to identify the relevant objects currently within the frame. Object detection is done by observing both the characteristics and dimensions of the contours found within the thresholded image. Object localizations are then sent to the AI system by providing both range and bearing values for any identifiable object. This effectively gives the robot a set of eyes and the ability to accurately assess the field.
The task of the AI and navigation system is to combine the other subsystems so the robot can obtain the ball and kick goals while avoiding obstacles. The AI system uses a model-based reflex agent, which can easily be implemented as a state machine for coding. This type of agent allows the robot to make decisions based on tasks that have been completed. For example, the robot must first obtain the ball before it can score a goal. To avoid obstacles, the potential fields method was used. Potential fields works by using the data from the vision system to calculate and sum the attractive forces of the goal object with the repulsive forces of the obstacles. This resultant force can then be used to calculate the velocity and angle the AI system needs to send to the drive system. With these forces constantly updating, it allows the robot to navigate constantly changing environments.
The drive system is based on an omnidirectional design, consisting of 3 omnidirectional wheels spaced at 120 degrees around the robot. The drive system consists of 3 stepper motors driven by a microcontroller, using hardware timers. The 3 omnidirectional wheels attached to the motors are encased by small rollers, perpendicular to the turning direction. The combination of steppers and omnidirectional wheels allows for precise movement along 3 degrees of freedom. The vertical, horizontal, and rotational velocity from the AI system is used to calculate the velocity for each of the 3 wheels. The rotational velocity of each wheel is then converted into steps per second for each of the stepper motors. The precise motion of the stepper motors enabling advanced functionality such as mapping to be implemented.
The kicking and dribbling subsystem was in charge of controlling the ball in order to achieve goals, while remaining relatively inexpensive and non-intrusive to the other subsystems. The simple design was based on prior RoboCup robots, while keeping this competition's rules in mind. Parts were initially sketched on paper, and then drawn up on AutoCAD, and prototypes of these parts were produced in many iterations which encountered many issues before reaching the final design. Most of the components were laser cut from HDF or acrylic, or 3D printed, and utilized low-cost, high RPM motors, which were powered from the drive system's motor control board. The final design successfully collected and maneuvered the ball into a goal, and succeeded in having very little impact on the final budget.
Overall on demo day, our robot was able to score 1 goal. Although it did not perform very well, it was actually scored.